Okay, number 1 and number 2 do not have learning targets because they're more just general about your knowledge of unit rates and ratios and proportions rather than a specific skill. So they're not really a learning target. So there will not be any check or an X for those two. Okay? Number 1, the correct answer was G. So go ahead, if you missed it, make sure you put an X also through number 1. Now I'll say this, that pretty much, I think we had about 5 people in each class get it right, which meant 15 to 20 missing it in every class, which is okay, but that tells me that I should see a lot of people writing down what I'm about to write down here. So I'm going to do it kind of off to the side. You guys, I think, have room below, I think. So you should be writing this down. So what I'm going to do is I'm going to go through here and show you why A, B, and C are all correct. You could use unit rate for all of them. So I'm going to make up situations in all of them. So first of all, letter A. To find missing measures in equivalent ratio problems. Okay. Well, let's put an A somewhere. Put it on your paper somewhere. And I'm going to give you an example. I'm going to say, let's say that I made 15 shots in 5 minutes. And the question was saying, well then how many, no, I don't want to do 20, I want to do, I want to change this a little bit. Did you guys already write that? Okay, make it 75 shots in 15 minutes. Go ahead and do that. So you don't have to really change anything. Okay? Now, if I said I want to know how many shots I could shoot in 40 minutes. Right, guys? Now, is there any way to go from 15 to 40? By a whole number anyway. No. Okay? So, when it says to find missing measures in equivalent ratio problems, this is what it's asking for. It's asking for something like this, where you're trying to determine exactly how many shots were taken in 40 minutes. Now, most of you would just line this up and you would cross, multiply, and divide, right, everybody? But here's my question to you. Could you use unit rate to figure out this answer? Absolutely. You could figure out how many shots per minute and then multiply it by 40 to figure out how many shots you would take in 40 minutes. So I know that I would be dividing by 3. Dividing by 3, that means that I am taking 15 shots per minute. Now I'm going to multiply by 40 and whatever that gives me. That doesn't matter. But do you guys all agree that I found a missing measure using unit rate? Would you guys agree with that? Yeah. So we know that A, I just proved to you, is one method of unit rate. Absolutely. You can always use unit rate to solve for an unknown. Okay, that whole problem is wrong, sorry. But I don't know what I was doing. Divide by 15. Divide by 15, it should have been 5 shots per minute, right? But regardless, you guys get the point what I was trying to make. Regardless, yeah, you can use unit rate to find an unknown, and that's the whole point. Okay. Now let's go to B. Give you an example of when B is used to determine when a pair of rates are equal. Okay, so let's say that I ran 4 laps in 2 minutes, and then I knew that I ran let's say 16 laps in 8 minutes. Now you know there are many different ways to check for equivalency, right? Right? Okay. Well, another way you could do it is you could always just figure out the rate per minute, right? You could just say, oh, I want to know per 1. That's going to be 2 laps per minute. And this one here would also be 2 laps per minute. So did I check for equivalency there? Did I prove that they're equal? And didn't I find unit rate? So would you agree that A and B are both correct? So basically by learning that, you've eliminated both A and B as your answers. So now we're either looking at either D or G. So now we've got to see C. Now, most of you that missed it put C from what I saw. So you knew that better by is an absolute use of unit rate. So I don't think I need to do an example for C because you know when you're finding the unit price or the unit rate, you're figuring out how many ounces per dollar or how many dollars per ounce or per pound or whatever. Right, guys? So absolutely, that would mean A, B, and C are all correct always, which would mean that G is the correct answer. Okay? So mark it wrong if you missed it. Okay, number 2. Now, this is the one that a lot of people are getting correct, but yet they're missing it because they're making one mistake, or they're not missing it. You're all getting it right, but you're going to miss the last question on the test because of your reasoning. So this is what I want to spend a little bit of time on. Okay? Now, when you see this right there, isn't that just your fake ratio, guys? You know that you're talking about 12 girls to 5 boys. Okay? If you add 5 boys and 5 girls to the roster, is the ratio of girls to boys the same? Well, most of you are like, well, can you ever add the same amount to both the top and the bottom and get an equivalent ratio? No. Now, unless it's this, unless you had a 1-to-1 ratio, right? Yeah. That's the only time you could add the same amount. But I think you guys see this word add, and you're getting a little bit of, you're not exactly right. Now, nobody put A. I mean, that's the good thing. Nobody selected A. I mean, you guys knew that this answer was no. But here's my thing. When I look through your test, I didn't see a lot of people actually checking C. And that's where I think the problem is lying here. Okay? Because I think what people are seeing is they're seeing this, and they're saying, oh, well, it can't be C either. Okay? The correct answer is B. But I want to make sure you guys understand something right now. This is really important. I want you all to write this somewhere. Write this. It's for questions like number 2 and number 38 or whatever it is on the last page. Okay? And here's my example. Let's say that I have 2 boys and I have 3 girls in my math class. Okay? Now let's say I added 2 boys and I added 3 girls. I would now have 4 boys and 6 girls. Here's my question to all of you. Here's my original ratio. Would my ratio now, would it be the same? Yeah. But wait a minute, I added, didn't I? So does it necessarily mean that you can never add or subtract to make equivalent ratios? I want to make sure you guys get this because I think I might have misspoke a little bit when I was going over this. You can add or subtract to make equivalent ratios. You can never add or subtract the same amount though, right? So what I'm saying to you on this, because I think you guys are all making the connection, am I just multiplying by 2 to both the top and the bottom? Would both of them have the same simplified ratio? Would both of them have the same decimal value after dividing? Absolutely. So I think a lot of you just discounted C because you saw the word add. But what you really should have done is you should have said, okay, I got 12 girls, I got 5 boys. Okay? If I add 6 girls, that gives me 18 girls. If I add 3 boys, that gives me 8 boys. And what you really should have done is actually taken this and actually checked for equivalency. So you could simplify this one, divided by 2, to 9 to 4. Are those the same simplified ratio? No. You could have also used cross products, 5 times 18 and 12 times 8. See if it gives you the same amount. It wouldn't. Does that make sense, guys? So don't just assume because it says add that you can automatically say, oh, those are not equivalent, because that's just not true. Okay? Because I proved down here you can't add or subtract to make equivalent. Okay? It just depends on the problem and what you're adding and subtracting. So you need to check. I could take this a step further and say, okay, I'm going to add 4, and then I'm going to add 6. That's going to give me 8 to 12. Is that the same ratio as that? Absolutely. Okay, so just be careful. Be careful. Okay, so the correct answer was B. No learning target on that once again. Okay. Number 3, the correct answer was B. And that was learning target number 5. Okay. Now, I'm sure that the majority of you in the room probably simply just cross-multiplied and divided, right? That's fine. But I just want to make sure you guys do understand that you could scale in this situation. And since you know the second term, what would be a good thing to... What would be a good number to scale to here? 3. So you're dividing by 4, dividing by 4. That's going to give you 4 to 3. And then times 3 would give you 12. So you could scale to 4 to 3. Okay? Unnecessary, but you could have. The correct answer is B. Make sure you give yourself a check or an X on learning target number 5. Okay, down here. These ones are all worth 1 point. So each one is going to be learning target number 1. So that means this one's going to be learning target number 1, number 1, number 1, number 1, all of them number 1. So that means this entire problem is worth 6 total points. Everybody got that? So I expect you to have 6 checks or 6 X's on learning target number 1. Okay? So, Mr. Garrison is throwing his 7th grade basketball championship party. He is making his world-renowned fruit salad. My recipe calls for 30 people, and it's going to contain 3 containers of strawberries, 6 bags of seedless grapes, and 12 whole oranges. Okay? So the fake part was already given to you, right, guys? It was already there for you. Okay? And then I even went as far to fill this in for you. And I had people asking me, like, where does this? Where did 10 come from? Where did 50 come from? And I had some people even thinking that this was 80. And my thing to them is, okay, so yeah, I didn't do a very good job writing that in, but it said it right here in the question. I may not even give you those on the summative, just so you know. I may not. Okay? Let's read A. If I'm only serving 10 people, only 10 people could make it from my team, I don't want to make a recipe for 30 people. That wouldn't make any sense, would it? I only want to make the amount that I'm going to need. I don't want to have a lot of extra cost for 30 people. Okay? So, you just look here and say, I want to make this recipe taste the exact same. Well, what did I do to my number of people, guys? I'm dividing it by 3. So if I'm dividing my number of people by 3, doesn't it make sense that I'm going to divide each ingredient by 3 also? So that would mean I would need 1 container of strawberries, I would need 2 bags of seedless grapes, and I'm going to need 4 whole oranges. So go ahead and give yourself 3 checks or 3 X's for that. Okay, now let's look at part B here. How much of each ingredient would I need to make an identical recipe now that serves 50 people? Okay, well, if I know how much, I don't have to go straight from 30 to 50. That'd be hard, wouldn't it? All I'm doing here, if you didn't notice, is I'm just scaling for you. Don't you realize that? I scale to a factor of both 30 and 50 just to help you. Okay, so what am I doing to my 10 people? Am I multiplying by 5? So what do I got to do to each ingredient? So that's going to be 5 containers of strawberries, 10 bags of seedless grapes, and 20 whole oranges. Give yourself another 3. So at the bottom, I need you to put what you got out of 9 on that part. The whole page. Alright, these here are going to be, let's just call this learning target number 5. We'll call this learning target number 5. We're going to call this number 6. And then we're going to call the next one number 5. Okay, those are kind of your learning targets there. Okay, let's go back up here. In the computer lab, there are tables and chairs. Well, the first thing I should do is what? I should do my edge pieces. That should be the first place I should start. And I know that the ratio of tables, that means the first number is representing tables, so I got 4 tables. 2, total furniture means 13's total. If you know that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total pieces of furniture, and you know that 4 of them are tables, how many do you have left over? 9 chairs. Okay? So, here we go. The ratio of tables to chairs is going to be 4 to 9. You could have written it any of the 3 ways. That's fine. Give yourself a check or an X on learning target number 5. No. What is the ratio of chairs to total furniture? 9 to 13. Okay. Now we're getting down to this part, okay? So, everybody watch. This is the work I expect. I can tell you that the answer is 39. I'll tell you that. But again, if your work is wrong, then it's going to be wrong. Okay? So, whenever you see the word if, you should know that what kind of information are you about to learn about? Real information, right? That's your real stuff. Okay? We have our fake stuff up here in the box. We are wanting to know, if this, then how many of this? That's the real information. So you should have all done a proportion. If you didn't, it's wrong. Okay? And then you just identify what labels they gave you and what are they asking for. They gave you chairs, they're asking for total, right guys? Yeah. So, where does total always go in a ratio? Bottom. So we got total. You might want to do TO because we got tables and total, so both start with T. And then we got chairs and chairs. The first ratio is my what ratio? Fake. So I go up and say, well, what is my ratio of chairs to total? That's going to be 9 to 13, right, guys?
Yes.
Now, I just put in my real information, and they gave me the actual amount of chairs, which is 27. This would be your X or whatever you want to call it. Okay? Then we know we're tripling our number of chairs, so doesn't that make sense that I would have to triple my number of total pieces of furniture, right, guys? Okay? Next one here, I can tell you that the answer is 54, but if you don't have the work, it's going to be incorrect. Okay? So, I know that they're giving me an amount of tables, and they're asking me for an amount of chairs. Okay? So my fake ratio of tables to chairs is 4 to 9, and they're giving me an actual amount of tables, which will put it there. What am I doing to my number of tables here? Eddie, head up. Times 6. So what do I got to do to my number of chairs? Times 6. So I'm going to get 54 chairs. I hope you're all writing this down if you're missing them. If you're missing them, you had better be writing them down. Okay? All right. This next one, we'll just go ahead and call learning target number 5 also. Okay? We start with our proportion, okay? J-Dog fouls out 9 out of every 15 games. How many games would he foul out if he played in 55 games this season? So, if you think about it, could you do edge pieces here? Yeah, because, okay, so that means, that fake ratio means right there, okay, he fouled out 9 times. So we'll put FO for fouled out. And we know that he played in 15 games. So those other 6 games up here, what happened in those ones? That means he did not foul out, right? No FO. No foul. Okay? He did not foul out in those other 6 games. Now, did you have to do edge pieces? No. You don't have to, but it's just a good way to keep your mind straight as far as what exactly your information you have is, okay? So, we just now got to look at the question, which the question is always going to be the real information. You can see there's the word if right there, kind of laying it out for you. It wants to know how many games he would foul out if he played in 55 games. So we know, aren't we talking about games or total games or something like that? Right, guys? You could have made that total or games, and then it's giving us an actual amount of foul outs, or asking us for an actual amount of times he fouled out. So we know our fake ratio is 9 out of 15, and we know that he played in a total of 55 games. Okay? Now you could have done this a couple different ways. You could have just cross multiplied and divided to get 33. Okay, that's the answer. But I want to make sure you guys all know you could also scale to a factor of both 15 and 55, which would be 5, right? Divide by 3, divide by 3. You know that he's fouling out 3 out of every 5 games. Now times 11 gets you 33. You did not have to scale. You could have cross multiplied and divided. 55 times 9 divided by 15. That's fine. But the answer is 33. You had to have a proportion with labels. If you didn't, it's wrong. Yeah.
So, if you like when...
On here. You could also figure out the unit rate. You could have, in here, rather than go to one game, you could have said divide by 15, found a unit rate. The only issue with that method is sometimes you get a repeating decimal, which is going to mess up your answer. Okay? There's no way to show a repeating decimal that goes on and on forever. So when you start rounding, you're not given the full answer. Okay? So just keep in mind, just set it up. Don't overthink it. Just cross, multiply, divide. That's fine. Okay? All right. This one here is also going to be learning target. No, this is learning target number 6 right here. Okay? Now I will tell you the correct answer is 72. So if you didn't have 72, you better be writing this down. Okay? We know that Gwen, she makes 3 out of every 12 total free throws. Could we have done edge pieces here? What's the only 2 outcomes that happen when you shoot a basketball? You either make it or you miss it. So that means if she's making 3 and she's taking 12 total, we know that she's missing 9. You didn't have to do the edge pieces, but I like to still just get the information all put somewhere that we can find it. So we read the question because that's going to have your real information. If she shoots this, then how many would this be, or whatever. That's what the question's going to be. Okay, how many free throws did she shoot? So that would mean 12 total, or just 12 shots total. Okay, I'm going to call it total because that's what it is. You didn't have to. You could also make it shots. That's fine. If she made 18. So we know we're talking about makes and makes. So that's our proportion. Makes to total, makes to total. My fake ratio says that she makes 3 out of 12. And then the real information they give us is that she makes a total of 18. You could cross multiply and divide, or just recognize that you're multiplying by 6. Multiplying by 6, you're going to get 72 total. I need to see that work. If it's not there with labels, it is incorrect. All right, next two here. These are both learning target number 7 now. Both of these are learning target number 7. Now, I warned you about this question, didn't I? I said, yeah, you could find the answer by just setting up a proportion. Yeah, you could go 18 inches in 12 hours. Well, then how many in 20 hours? And you could cross multiply and divide. Does everybody agree you could find the answer that way? You could. But these directions right here specifically ask you to show the unit rate, which is what Ben was just describing on 2 problems ago. He did it. You can always use this method, but it's not a great method when you're talking about decimals. So, what I would expect to see here. First of all, I know that's my fake ratio right there. Let me erase this so I can get in here. Okay? That's my fake ratio. Does everybody agree with that? Now, since it gives me a real amount of hours, would it make more sense to figure out the unit rate per inch or per hour? Per hour, because it's giving me a real amount of hours. And I know that if I know a real amount of hours, then I want to figure out how many inches it's going to snow in 1 hour. So that means what label is going to go on the bottom? Hours. And I'm going to figure out a unit rate, just like we did in chapter 4. So we put our fake ratio, 18 inches in 12 hours. What am I doing to go from 12 hours to 1 hour? So what do I got to do to 18? And I'm going to get 1.5 inches. I had people asking me during the test, is it okay if I get a decimal here? Absolutely. Is it possible to have 1.5 inches of snow? Yes. Okay. Now you could have done this in 3 different ways here. For one thing, I had to see this. If you didn't show this, it's wrong right away. You better be writing this down. Okay. I can tell you the answer's 30. But it's all about the work more than it is about the answer in this case. Again, if you did not show, it says use and show a unit rate. If you found it to 2 hours, you're not finding a unit rate. You're finding a ratio per 2 hours. Okay? Everybody got that? You had to show the unit rate. You had to show unit rate. Everybody understand? Because the directions specifically say the learning target actually says I can use unit rate to determine an unknown. The unknown is how much it snowed in those 20 hours. So here's the 3 ways I'm going to accept right from here. Okay? You must have the unit rate on there, obviously. Now, here's the first way. The best way. Whoops, sorry. The best way would be to then take that unit rate, 1.5 inches in 1 hour, and then figure out, okay, well then how much in 20 hours? Times 20 times 20 gives you 30. That's the first way you could have done it. Good job if you did it that way. That would probably be the best way. 30 inches in 20 hours. The other way I'll accept is you don't have to necessarily rewrite this entire unit rate again. You have the unit rate right there. Just make another proportion. Times 20 times 20, you get 30 like that. That's fine too. You're technically doing 2 proportions, right? You have 1 proportion there, and then instead of just rewriting it, you went ahead and just used it there. You see how that works? And the last way that I'm going to accept, because I feel like you understand what's going on, is if you have this right there, and then you know that it's 1.5 inches in an hour, then you could do 1.5 and just go ahead and multiply it by 20. I will accept that also to get 30 that way. Everybody understand? I will accept that as well. Okay? All right. Next one. These are learning target number 7. Okay? A race car can travel at a speed of 186 miles in 3 hours. How far can it travel in 5 hours? Once again, this is a use unit rate to solve. If you did not use the unit rate to solve, then it is incorrect. The correct answer is 310. So if you didn't get that, you better be writing something down so that you have something to study off of. So since it gives us a real amount of hours, doesn't it make sense that we're going to figure out how fast he goes per hour? Oops. In 1 hour. So we know this is hours on the bottom, miles on the top. I know that it's 186 miles in 3 hours. Divide by 3, divide by 3. You end up getting 52, I think. Or no, 62, I'm sorry. Right? 62 miles in 3 hours. Now at this point, you could have just taken 62 and multiplied it by 5 to get your answer. Or the better way would be then to do another proportion and then times 5 times 5. You end up getting 310 miles in 5 hours. But again, I have to see the unit rate. If you did not use it, it is wrong. Okay? Okay, these next ones, these are all worth 1 point, all of these. So all these are learning target number 8. Everybody got that? So you're going to have 5 different checks or 5 different X's on learning target 8 just from this. I need to see proportions of all these also. So the first one I'm going to do is I'm going to do oranges here. Okay? My oranges are right here. I know that when I'm doing unit price, what label has to be on the top? Money. If you didn't do proportions, it's wrong. So just count all 5 of these wrong if you didn't do proportions. Or at least 4 of them. These 4. Okay? But then you must also have money on the top. Money on the top, oranges on the bottom. My fake ratios right here in the table, it says that 7 oranges cost $3.50. I need to figure out the unit price, which means how much 1 orange costs. So I'm going to divide by 7. Divide by 7. It's going to be 50 cents per orange. If you left it as 0.5, count it wrong. I will not accept 0.5. That is incorrect, absolutely. It is 50 cents. What?
We can do a cent sign, right?
No. Not on this one. 50 cents. We don't do a cent sign anymore. Okay, I'm going to accept it on one problem on this test, and that's all. If you have... Did you put 50 like that?
I went 0.50, then I put the cent.
I'll accept it. Okay, but I must see 0.50 on there. Okay, number 19, here we go. Again, I'm going to put money on top, so that's $1.95 for, I think, 5 kiwis. I need to know how much 1 kiwi is. Divide by 5, divide by 5. It's going to give me 39 cents per kiwi. Okay, the plums cost $2.43 for 9 plums, right, guys? I need to know how much 1 plum costs, which is going to be 27 cents. 27 cents. You may want to be writing this down then. Divide by 9, divide by 9. And then finally, I know that it costs 93 cents for 3 pairs. I need to know how much it costs for 1 pair. Divide 3, divide 3. I'm going to get 31 cents. So right there, those are all learning target number 8. Give yourself a check or an X. They're all worth 1 point. Yeah, all separate. They're all separate points. Okay. Next one here. This is also learning target number 8. So if you know how much 1 costs, can't you just multiply it by however many you're buying? So I know that each kiwi is 39 cents. Can I just multiply it by 4 to get $1.56? And then if I know how much each pair costs, which is 31 cents, times 2, I'm going to get 0.62. I'm going to end up getting $2.18. If you use proportions on that, good job. You probably should have. Okay? At the bottom, this one is worth 13. At the bottom, put what you got out of 13, please. Okay, here we go. The rest, these next 3 here are all worth 1, and they're all learning target number 8. All worth 1 and all learning target number 8. Okay. Which store is offering the better deal? Well, it kind of says per ounce, so it basically makes it very easy on you. So you know that ounces has got to be in the second term. If it's not in the second term, then it's wrong. So you know, here's your first proportion. This is going to be target over here. Ounces in the top, ounces in the bottom, money in the top. If you didn't do that, it's wrong. I know that Target has a 16-ounce box for $5.60. I need to know the unit price, how much per ounce. So I'm dividing by 16 to both the top and the bottom. I'm going to end up getting, what is it? 35 cents. There we go. Now I'm going to do the same thing for Kroger, which I'll do in blue. Okay. And again, I'm going to do my labels, money in ounces. If you didn't have labels, it's wrong. In ounces. Their ratio is they are selling a 20-ounce box for $6.20. So I need to figure out how much per ounce. Divide 20. That's going to give me 31 cents. So which one's offering the better deal? Obviously, it is Kroger. So you must have everything I have there and the fact that the answer is Kroger. That's fine. Okay. Yeah. Okay. All right, how much will you save then? Obviously, if you know that at Target it was 35 cents, at Kroger it's 31 cents, then we know that you would save 4 cents by shopping at Kroger. 4 cents per ounce. If you put 4 with a little cent sign, I'll accept it. I shouldn't. That cent sign is garbage. Let's not use it anymore. It's something that's used in elementary school that's never used ever again in life or in every other math class you ever take. We don't use that sign, so don't put it. If you had 0.4, it's wrong. You either had one of two things. You either had this, 0.04, or I'll even accept this, even though I should. Those are the only three things I'm going to accept. Okay, here we go. This one, there's actually 2 answers I'm going to accept on this one right here. Okay, you've completed 8 miles of a 10-mile race in 32 minutes. I mean, the easiest way to do it is just put your fake ratio on there. 8 miles in 32 minutes. And then just say, okay, well then how much would a 10-mile race be? Right? That's probably the easiest way. Cross, multiply, divide. You're going to end up finding that it would take you 40 minutes. Okay, now there's other ways you could have done it. You could have found a unit rate. You could have realized that it's 1 mile every 4 minutes. And then it's like, well, okay, so if I was running 10 miles, times 10 times 10 would be 40. Now, what I'm going to accept also is I'm going to accept 40. I will also accept 8 miles. Okay, and the reason why is because some of you interpreted the question as, how long would it take to finish it? Well, it would take 8 minutes to finish it, right, everyone? If you're running 1 mile every 4 minutes and you've completed 8 out of 10, that means you have 2 left. So isn't the proportion 1 mile every 4 minutes? Isn't that going to be 2 minutes or 2 miles in 8 minutes? So 8 plus 32 is definitely 40. But I'll accept both. I'll accept 40 and I will accept 8. The reason is, again, is because if you interpret it as how long would it take to finish it, it would be 8 minutes. But the reason it's 40, the real answer is 40, is because it wants to know how long it would take you to complete the entire thing, all 10 miles. Next thing, these are all learning target number 9. All of them are learning target number 9. Now I'm going to tell you all right now, if you did not show proportions, they're wrong. You may as well give yourself 5 X's right now, because I taught you to use proportions. Okay? And remember, this is how I taught you to start them. Please watch. I said you always look at what labels are being compared. We know we're talking about quarts and we're talking about cups. Quarts to cups. If you did it without labels, it's wrong. Okay? Now remember, your fake ratio for this type of proportion is just your conversion. There are this many of this and that. So I know that there are, in 1 quart, there are 4 cups. Then I just look and say, okay, well then how much is 3 quarts? Times 3 would mean 12 cups. I have to see this work. If you don't have what I have highlighted in green, it's wrong. Here we're doing feet to inches, feet to inches. My fake ratio is that 1 foot equals 12 inches. How do we have a question on this? Okay, yes, you can. It doesn't matter when it's part to part. Remember, if you're comparing quarts to cups, you can have it flipped. Technically speaking, I guess the 1 should probably be in the second term, but it's, I don't know if I'd really consider that a unit rate. I guess it is, but it doesn't matter on any of these. You can have them all flipped over. So I want to know 15 feet times 15 times 15. That's going to be 180 inches. Again, you must have the proportion. Next one, I'm comparing tons, which is shown by a capital T. And then pounds is LBS. Okay. I know that in 1 ton is 2,000 pounds. So if I want to know 2 tons times 2 times 2 is going to give me 4,000 pounds. Okay. Class 2. Here we got ounces to pounds and ounces to pounds. I know that there are 16 ounces in 1 pound. I need to know how many pounds is in 48 ounces. So that's times 3 times 3 would be 3 pounds. You could also cross multiply and divide as well. And the last one, I know that I'm comparing meters to centimeters, meters to centimeters. I know that 1 meter is 100 centimeters. So 28 meters would be times 28. And times 28, it's going to give me 2,800 centimeters. Okay? At the bottom, this page is going to be out of 8. So put what you got out of 8, please. Okay? These first 2 here are going to be learning target number 3. Number 3 and number 3. Now, I made it pretty easy for you guys. I didn't make you model it. I made you interpret a model, right? Which is a whole lot easier. Does everybody agree with that? Absolutely. A lot easier. Okay? So, it gave you the fake ratio, which was 5 to 3, cranberry to apple, and then it gave you a total amount of milliliters. Okay? Well, if you know that all of these are represented by 200 milliliters, then don't you want to do 200 and divide it by all your rectangles? Divided by 8. Isn't that going to mean that there's going to be 25 in each one of these sections? Okay. So 25, 25, 25. Now it's easy. Okay. How much apple juice do you have? Well, 25 times 3 would mean 75 milliliters. Okay. What is the volume of cranberry? Well, it's going to be 25 times 5, which is going to be 125 milliliters. Everybody agree with that? Could you also have used proportions here? Sure. Absolutely. If you wanted to come up here and say, okay, it's asking for apple, and it gave me a total. So we're talking about apple to total, apple to total. My fake ratio would be 3 to 8, right? With my total being 200. Cross multiply divide, you would get 75. Here, we're doing cranberry to total. Cranberry to total, and that would be 5 to 8 with a total of 200. Okay? Okay, there we go. So that was pretty easy. This one here was even easier. It said that Jack Ayers made 140 shots in 7 minutes. By the way, this is learning target number 4. Okay, model to find the amount of shots he made per minute. Well, if you know that those 7 right there is representing 140 shots, don't you just want to do 140 divided by 7 to get 20 in each? You don't even need to cover them in because you know now that 1 represents 20. So that means he makes 20 per minute. Pretty easy there, I think. Right? Learning target number 4. Okay, next one. I was trying to get you to scale. You had to scale here. Okay? And since we know the number of pens, we want to scale to something. What would be a good number to scale to right here? Yep. 1 would work, but there's a better one. Yeah. Yeah, you always want to use the greatest common factor, right? You could have also used 1. Then you can divide your number of pens by 2. And then you are going to divide your number of money spent by 2. You could also use 30 as your scale number. That's fine. Then what are you doing to your number of pens? Times 5 times 5. So that's going to be $10. Okay. Now that we know this is 10, we can just add on to our table here and say, okay, well, if I want to spend $20, I'm just multiplying by 2. So that means he's going to have 30 pens. And I just showed it within the table, what it says. Huh?
You have to show it in the table.
Did you show a proportion down here?
Yeah.
It's fine. Good. If you showed a proportion down here, now this one here you had to scale. For how much will he spend? You had to scale to something here. Had to. It says it. Now, for this one, these are learning target number 1. Okay. This page is worth 5. Yeah, I'll accept it. Okay. It's out of 5, this page. Let's go on the next page. Okay, here we go. This table right here, what you see, going to be highlighted here in a minute. This is all worth 1 point. Everybody got me? It's learning target number 2. Either you got the table right or you didn't. Okay, so I look at my number of cups of ginger ale. And I say, okay, what am I doing to those? Times 2, right? So what am I going to have to do to my number of my cups of fruit juice?
Times 2.
So that's going to mean 8, right? Now what am I doing to my number of cups of fruit juice to go there?
Times 2.
So what do I got to do there?
Times 2.
20. Okay, now we're going to plot the points. I guess I should fill this in. You must have done this. 4, 5, 8, 10,
Do we have to
and 16. No.
So 5 check.
No. I just said this is worth 1 point. So it's 1 checker, 1 X for all of it. Okay, now let's plot it. This is going to be another checker and X. Okay, so I need to plot 4, 5. So I'm going to go 4 up to 5. There's my first point. Over to 8, up to 10, right there, I think. And then 16 up to 20 is right there. Okay, now we obviously need to draw a line through these. If you didn't, it's wrong. If you didn't, it's wrong.
Wait,
Yep.
I did draw a line down to
No, you can start it right here. This is learning target number 2. So that's worth a point right there. Just the graph itself is worth a point. Describe the pattern in the graph. This is something that I spoke about in the learning target number 2 video, if you'll remember. You could go back and watch it and hear it for yourself. But I said whenever it asks you to describe the pattern, I'm looking for one word, and it's this word right here. Is the pattern in a constant rate or in a varying rate of change? What is it? Absolutely constant. It's saying for every 4 of the ginger ale, or the fruit punch, then it's 5 of the ginger ale. Okay? I will also accept that for every 5. Okay? I'll accept that. That's also learning target number 2. And the last one. Okay, now I'm just going to tell you right now, this is the one that everybody missed. Okay? The answer is yes, it will. So if you did not put yes, you had better be writing down what I'm about to write down. Okay? Now, just get that at the end. Get that at the end. Just wait. Okay, so the answer is yes. And here's why, guys. Again, you're getting caught up in the word add. She's adding cats. But you can still have an equivalent ratio even if you're adding, and here's why. So, she has the ratio she has at home is she has 3 gray cats to 9 orange cats. Everybody agree with that?
Yep.
Everybody agree? So, she goes and she falls in love with these 8 cats, whatever. Okay, so then she's going to add 2 more gray cats to what she already has. So how many gray cats is she going to have now? 5 gray cats. And then she's going to add 6 orange cats to what she already has. How many orange cats does she have now? Now, do you know many different ways to check for equivalency? Absolutely. You could use cross products. Wouldn't both of those equal 45?
Yes.
Okay. Okay, that's one way. Another way is just to simplify them. Wouldn't that simplify to 1 to 3?
Yeah.
Wouldn't this simplify to 1 to 3? And then we could divide it. 0.3 repeating, 0.3 repeating. So right there, you didn't really have to explain it because you just had to show it. And that's what I'm talking about. That's why a lot of you missed it because you saw the word add and you're thinking it means something that it really does. Okay?